talk about how to do some factoring here of trinomials, and I'm going to show you another method called the box method. It's really similar to what I put in class when I made the quadratics and I made the little rectangles and stuff. We're going to go backwards that way. So let's look at, I'm going to look at number 1, number 2, and then we'll attack number 4. So let's look at number 1 first. When I start a trinomial, if the x squared term is just x squared, if it doesn't have another coefficient in front of it, so we basically have a 1x squared minus 6x plus 9 here, then all I have to do are find numbers that multiply to 9, multiply to the constant term, and add to the negative 6, which is our x term there. Okay, now here are a couple tips. Because that 9 is positive, I know that both of my numbers either have to be positive or they both have to be negative. That's the only way that they're going to multiply to be positive 9. All right, so let's think about that. If I have a 1 and a 9, adding those together equals 10, so that's not going to work. So 2 won't work because 2 doesn't divide into 9. Let's try 3. That means the other number has to be a 3. And 3 plus 3 equals 6, but that's a positive 6 and I need a negative 6. So that's telling me that some of my numbers have to be negative to make that work out. So I'm going to try a negative 3 times a negative 3. And sure enough, those are my two numbers. Okay, so here we go. Now, when the first coefficient is 1, really all I have to do now is write my factorization. I take whatever my two numbers are and I take x minus those two numbers. Okay, but I could do it with a method called the box method. So here's what I do with the box method. I put my x squared here and my 9, and then my two numbers, what I do is I put minus 3x here and minus 3x here. Whoops, that's an x squared. And now I factor to the left. On the first one I can factor out an x, and on the second one I can factor out a 3, but that minus is telling me I'm going to factor out a minus 3. And then I factor down as well. So x squared and minus 3x, I can factor out an x. And here, a 3 and a 9, so I can factor out a 3. But again, that's negative, so I'll factor out a minus 3. And here's my factorization. X minus 3 times x minus 3. So there's the first one. Let's look at number 2. So I'm going to erase all of this except for what we had. I'm going to copy that. I'm going to erase it all and I'm going to put that back in. And let me take this little guy out. So now let's look at the second, or the second one I think I said I'd do. And again, the x squared term just has a 1 on it. So I'm going to look for things that multiply to a 25. And add to a 10. And again, the 25 is positive, so I know I'm either going to have two positive numbers or two negative numbers, because when I multiply those numbers to get 25, if they have opposite signs, that would give me a negative 25, not a positive 25. So let's see. If the first number is a 1, then to make it multiply to 25, the second one has to be 25. And when I check it, 25 plus 1 is 26, so that's not going to work. 2 doesn't divide into 25, so that's not going to work. 3 doesn't divide into 25. 4 doesn't divide into 25. But 5 does divide into 25, and so the second number also has to be a 5. And then I'll check 5 plus 5, and that's 10, and that's what I need. So those are my two numbers, 5 and 5. And again, I'm in the situation where my first number is a 1, so I can just write x plus 5 times x plus 5, and I'm done. There's my answer. But if I want to use the box method, again, I'm going to break it up. My x squared and my 25 go here, and then I'm breaking this into 5x and 5x. I'll factor to the left. I can pull out an x here, and here I can pull out a 5, and then I'll factor downwards. I can pull out an x here, and I can pull out a 5, and those are positive, so plus and plus, and I get x plus 5 from this one, and x plus 5 from that one. So there's the second one. Now let's look at the third one, or the fourth one. I'm going to skip the third one, but let's look at the fourth one. This one is different because I don't have a 1 in front of that x squared term. So I am going to use a similar method, and this is the factoring by grouping that was also asked in class. All right, but I'm also going to do this with the box method and see if this is going to help. So the first thing I do is now, instead of looking for things that multiply to 9, I take 4 times 9. So I want things that multiply to 4 times 9, which is 36. Whenever your lead coefficient is not a 1, you have to take that lead coefficient times your last term. Okay, so I want things that multiply to 26, but again, things that add up to 12. And again, that 36 is positive, so I'm either looking for 2 positive numbers or 2 negative numbers. And I'm going to start trying to figure it out. If the first number is a 1, then to make it multiply to 36, the second one has to be a 36. And 1 plus 36 is 37. That's not going to work. If the first one is a 2, to make it multiply to 36, the second one has to be an 18. So I'll check. 2 plus 18 is 20. That's not going to work. If the first one is a 3, to make it multiply to 26, the second one has to be a 12. 3 plus 12 is 15. That's not going to work, but notice I'm getting closer. 37, 20, 15. So hopefully we'll be there pretty soon. If the first one's a 4, then let's see. Oh, the second one is a 9 because it has to multiply to 36. And 4 plus 9 is 13. That's not going to work. Let's see. 5 doesn't divide into 36. If the first one is a 6, if I have to multiply it to make 36, then the second one also has to be a 6. And 6 plus 6 equals 12. So those are my two numbers, 6 and 6. Now I'm going to jump right to the box method. My 4x squared is going to go here. My 9y squared is going to go there, the first term and the last term. The middle term I break up into 6xy and 6xy. Okay, so I use my two numbers, and instead of writing 12xy, I've broken it up into the 6 and the 6. Now I factor to the left. Let's see, between 4x squared and 6xy, I can pull out a 2x. Yeah, that's all that's common. Between the 4 and the 6, 2 is the biggest number. And between the x squared and the xy, I can pull out just an x. And then down below, right here, between the 6 and the 9, a 3 will come out. And there's also a y on both of those, so I can pull out a y also. And then I factor downwards. So now between the 4x squared and the 6xy, I have a 4 and a 6, so I can pull a 2 out. And an x squared and an xy, I can pull out an x. And now I'll do the 6xy and the 9y squared. I'm looking at the 6 and the 9, and I can pull out a 3. That's the largest number that divides into both of those. There's not an x on both of them, but there's a y and a y squared, so I can pull out a 3y. Everything is positive, so I know that's positive and that's positive. Oops, I made a mistake. That was a 3, not a 9. I hope that you caught that earlier and you were wondering, how did she do that? Okay, so now my factorization, 2x plus 3y, and down here, 2x plus 3y. And there's my answer. I find the box method to be really the easiest method when I'm multiplying things that have a first lead coefficient that's not equal to 1. The book talks about the grouping method, and that's fine, but I really do like the box method. I also want to point out one more thing, and that is when you factor, factoring is not easy. It's an example of what's called an inverse operation, which is kind of like going backwards. We're going backwards from multiplying. And inverse operations are not easy. Okay, they're not as easy as doing like forward operations. But one advantage to inverse operations is you can always check your work. And if you check and you see that something's wrong, sometimes you can see where to make the adjustment to make it work. So whenever I factor, I can always come back and check my work. So let's do that. I'm going to use the FOIL. So my first is going to be 2x times 2x, which is 4x squared. So far, so good. Sorry, that's my phone in the background. I'll get rid of some of this also. My outsides are going to be 2x times 3y, which is 6xy. My insides are going to be 3y times 2x, which is another 6xy. And my lasts are going to be 3y times 3y, which is 9y squared. And when I combine those terms, I get 4x squared plus 12xy plus 9y squared. So I know that I've got the correct answer because it multiplies back out. You can see when I use the box method, it's really trying to recreate what that O and that I are for the FOIL method. We're trying to do that backwards. We're trying to unfoil it. But I'll stop with that. That's kind of going off on a tangent. Anyway, I hope this was helpful. Please let me know in class, okay?